S stands for support, V stands for vector, and M stands for meshes. Support vector meshes is the full form of SVM. So in today's class, we are going to see how this SVM will classify this algorithm, how it is going to classify the records. Okay, so just we'll observe in this algorithm how it is going to classify. So here, whatever we are having SVM is support vector meshes. Now here I'm having a data that is x1 and x2 and y variable. x1 and x2 and y variable is there, and where I'm having the data points like this. Now here, if any new data point, some new data point is there, assume this is a new data point. For k and n, what we are going to do means we are identifying the nearest neighbors and we are going to classify. That is very simple algorithm. Simply we are going to complete. Now when it comes to the SVM, how it is going to classify means here, just by separating the two groups by using a line, we are going to draw one line, and using a line we are going to separate them. The data points will be separated. Now here if this is one of the line, this is one of the line, this is one of the line, like this infinite number of lines are there to separate. Now out of all these infinite lines, which line is the best fit line means which has the maximum margin. So for every line, it will take the support vectors. For example, this is the line. For this line, support vectors. What is meant by support vectors means from which the other class will start. That is called as support vector. To understand this example in a simple way. So for example, we are having two villages. This is village number 1 and this is village number 2. Okay, village 1 and village 2, or city 1, city 2, town 1, town 2, whatever that thing. Okay, now we are having two cities or two villages. Now for every city, starting point will be there, ending point will be there. Now ending point of this village, I assume that first village is ending here. This is the last point of this village. I mean what we used to call as the end point. The end point of this village. The end point of one village is the starting point of the next village. So from where the villages are getting separated, the point will be there, right? That point is considered as the support vector. So in this case, if I take a support vector in this way, if I draw a line like this point is the support vectors. So these 2 points will be considered as support vectors. Above these data points, everything is considered as green class, and below this one is considered as red class. These points are considered as support vectors. Okay, base from where the another class will start. That is called as support vectors. So for example, if you are taking one more line like this, sir. Now for this case, what is the support vector? For this case, in this example, what is the support vector? Means the green point, this is the support vector and this is the support vector. Okay, if you draw a line like this, these are the support vectors. For example, if you draw one more line like this is the line. For this line, what is the support vector? This one and this one. If both are same. If both are not same, means this one only this, which is the least one from where the second class is getting started. Okay, that is considered as the support vector. Now, if I draw a line like this, now I'm going to calculate the support vector, the distance I'm going to calculate. And if I take one more line like this, I'm going to calculate the distance. Here also I'm going to calculate what is the distance. Distance will be there, right? Distance I'm going to calculate. If one more line is there, if one more support vector is there, I'm going to calculate the distance. One more line, support vector distance for one more line. Like this, out of infinite number of lines, which line is the best one means which is having the maximum margin. Which line has on the both the sides maximum distance. That is called as support vector. Okay, this is called as